Introduction for this project. The main goal of this project is to create a program using the Python language that can analyze the statically indeterminate beam. This project aims to provide a straightforward and accessible tool for engineers and students. This program will help the student and the user to understand how statically indeterminate beam respond to different loads and setup by calculating the key factor such as the shear force, bending moment, and direction. This figure shows that the design of the statically indeterminate beam that we use to program it. The user must input the value of force in undistributed load, and the user must input the length of the beam by the section.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Zahanuddin. My number matric is DF220148, and today I will present about the algorithm, which consists of the pseudocode and the flowchart. Okay, what is pseudocode? Pseudocode is an artificial and informal language that help programmers develop algorithm. It is a semi-formal English-like language. So it begin with the input and declare uniform distribution load and the length of the member, and then looping the force and distance if the value is below than 0, and then calculate the fixed and moment, which is FEM, stiffness K, and moment M. After that, calculate the reaction force, and lastly display the moment and reaction force. That's all for the pseudocode. Okay, first, what is a flowchart? Flowchart is a diagrammatic representation of the algorithm. It starts with the declare the variable length, load, elastic modulus, and the moment of inertia. After that, input the variable x, y, z, a, b, c, e, and I. And then, if both distance is below than 0 and is true, it should be invalid value, and user need to input the variable again. If it's false, we continue to calculate the fixed and moment, stiffness, and the moment. After we calculate, if distribution is equal to 0 and it is true, we need to proceed to calculate the moment and the reaction force. If false, we need to first find the new carryover factor, and then we calculate the moment and reaction force. After we calculate the moment and reaction force and it is equal to 0, we display the reaction force upward and the moment is clockwise. It is false and not equal to 0, we need to display the reaction force downward and the moment is anti-clockwise. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Rahman bin Azman, and I will be presenting about program validation. So first of all, we will put these values into input validation. First of all, load A 5 kN per meter, load B 10 kN per meter, load C 5 kN per meter. And then for length span of AB, BC, and CD all have 5 meters. You can see below that our manipulation and our program calculation tallies, and it's the same. So we will just go through. Member A, AB, moment is 0 and reaction is 9.087. And then for member B, first we will go for BA, 17.064 and negative 17.064 for BC. And the reaction is 40.913. And for member C, we will go first CB, 17.064, then CD, negative 17.064. The reaction is 40.913. And lastly, member CD, 0 moment and 9.087 reaction.
So now we move to program user manual. First is overview. Overview is the introduction of this manual. Next is system requirement. So the device used must be Windows 10 or higher, have 32 RAM, and minimum disk space is 300 GB. Next is installation. So how to install the Anaconda? First, you need to visit the official Anaconda website. Then click download. After that, run the installer and follow the on-screen instruction. After complete the installation, you need to activate the Anaconda. So how we do it is, after installation, launch Anaconda and follow the prompts to activate your license. If you don't have a license, you can use your student email. After activating the Anaconda, you can launch the program. So how to do it is, first launch the Anaconda, then go to home page, select Jupyter Notebook and click launch, then upload the file from the saved location, open the file and run the program. Now you are ready to use the analysis of the resultant force calculator. So, how to use the program? First, you need to enter your name, university and your year study. Second, you need to enter the load A in kilonewton and make sure the load not less than 0, followed by B, C, and the length of first length, second length and the third length. Then you need to enter the elastic modulus in GPa and moment of inertia in millimeter to the power of 4 for every length of span, and make sure the moment of inertia not less than 0. After you insert the input needed, the calculated moment will be displayed.
Okay, to use our code, the first thing is to download the Anaconda navigator. We need to download it in the internet. Just click the download button for free, and then open the Anaconda navigator and click on the Jupyter Notebook. This is the one. Okay, we need to upload the code that we write. Okay, and then we need to open it. Okay, this is the code that we write. We need to click run and put our name, our university name, and the years of study. And then we need to input our load in kilonewton for A, B, and C. We need to input our length, the elastic modulus for section A, B, BC, and CD, and the moment of inertia for 3 sections. And then we can see our result here.